Recording is on. Here it goes. So, how was the quiz? Last quiz, quiz number 6. How was it? All good?
It's simpler than the rest.
Yeah, it's easier.
Okay, that's why I said to you earlier that you try to score 15 out of 15. I was purposely I said it a bit easier so that you can gain some sort of confidence for your anthem exam. So just try to get as much as in anthem exam. It will be a kind of moderate level. Try to attempt it. And 2 hours of time will be sufficient. I have already shared a set of instruction, guidelines for the final term exam. So that is there on the announcement. You must read that. You must read that. And I will be not there for invigilation. So you just have to handle in a best way. So please read it nicely. And if in case of any doubt before the exam, just ask me. Hope that is fine. Okay, let's start today's discussion. Today's discussion is on correlation and regression. Again, this is the last chapter in your course, correlation and regression, and the week 13 is a complete revision. So this is the last one. So we are almost towards the end of our learning. So let's go through this small case. What it says. When conducting experiments and analyzing data, many people often confuse with the concept of correlation and causation. So we'll deal with, in the correlation and regression, we'll deal with these two. Primarily, we'll try to understand what is correlation and what is causation. Causality. Okay. So Brandy works in a clothing store and she is restocking shelves. She notices that the sweaters are completely gone. I mean, one of the item is completely gone from the shelf. So she goes into the inventory area or some warehousing where it was kept to store and find the sweater boxes. In the meanwhile, she gets a call or another one of her co-workers is calling in sick. And that's the third person this week who fallen in the sick. And as she restocks the sweaters, Brandy has a thought. Are the sweater sales causing her co-workers to become ill? Brandy is faced with a common problem. Is it a correlation or is it a causation? So just keep this small case in mind. You will be able to unpack by yourself. Is it a case of correlation I'm talking about, or Brandy is thinking about, or she is thinking about, or is it a case of causation? Causation is causing A causing B, X causing Y. So correlation is just, so we'll try to have a discussion around this. So what is correlation then? So you probably know that a correlation is a relationship between two sets of variables used to describe or predict information. So remember, for the correlation, minimum two sets of variables has to be there. It's a correlation. So it's a kind of relation among or relationship in between. So it can be more than two variables, but minimum two variables has to be there. What are the other conditions for the correlation? There is an emphasis here on relationship. Sometimes we can use the correlation to find causality, but not always. So the first steps could be finding the correlation. Is two students or two variables are correlated, and then is there any causality among these two, or either A leads to B or B leads to A. We are not certain, we are not sure, but is there any causality? So that could be a second stage, but the first one is correlation. Are they correlated to each other? Remember that correlation can either be a positive or negative. So we'll see that the correlation with the characteristics of correlation, it varies. It could vary. The value of correlation could vary from -1 to +1, including 0. 0 means no correlation. Okay. So in statistics, it is often useful to determine the linear relationship, if any, between the two numerical variables such as age and weight and height, years of education and salary, or amount of daily exercise and your BMI level or the cholesterol level. So always in statistics or in the real life situation scenarios, we always very keen to understand, is there any relationship between the variables? So only the relationship you are interested in understanding, that is correlation. But is that relationship one follows others, one leads to other? So that is the case of causality. So let's X is explanatory and Y is the response, denoted the two variables. So one of our primary concern is to determine whether there is a linear relationship between a pair data or not. So it should be noted that this point is very important. It should be noted that a statistical relationship between two variables does not imply that there is a causal relationship between them. So there could be a cases, there are several cases where only the statistical relationship has been established. I mean, the correlation has been established, but saying that the same correlation variable will also explain causal relationship is not, maybe not possible, or maybe not. So you need to be very much careful. You can say that these two are correlated but not in the causal relationship, or you can say, or you could say these two are correlated along with the showing the correlation, a causal relationship. So there is a very famous experiment on ice cream. How do you think the ice cream kills? Do you think the ice cream leads to more fire, forest fire? Do you think ice cream leads to more accident or death? Is it a correlation or causation? So try to unpack this one. Or another example, like smoking is correlated with alcoholism. But do you think it is a correlation or is it a causation? Can we say that smoking leads to more alcoholism? No, but there could be a case of correlation between these two variables, these two constructs. So we have a very good, as I said, a very good example regarding the how ice cream kills. So let's watch this small video recording is started here.
Like most people, I enjoy a tasty scoop of ice cream, especially Oreo blizzards. But what few people realize is how dangerous a treat ice cream has become. First, there's the issue of obesity. Second, there are higher crime rates. Third, there's the loss of life due to a rise in the number of drowning deaths. And finally, as more ice cream is sold, there's an increase in forest fires. Given these indisputable facts, I need you to support my vision of an ice cream-free world. While banning ice cream trucks from entering your neighborhood may sound far-fetched, when it comes to problem solving, a common issue is misunderstanding the difference between correlation and causation. This misunderstanding can influence our decisions, sometimes with serious consequences that ripple throughout a community. Correlation is when two things are related, but one does not cause the other. Usually this means the two are in some way related to a third factor, but not always. If you have a big enough pile of data, you can find plenty of relationships that are purely coincidental, like the strong relationship between the sale of margarine and divorce rates in the state of Maine. With the sale of ice cream, the third factor is weather. When it is hot outside, people buy more ice cream. They are more likely to go for a swim, and there is a general increase in people out and about enjoying the weather, helping improve conditions for crime to take place, as well as the dry conditions associated with forest fires. A note of caution, there's a growing trend in our digital world called data dredging. This is using analytics to sift through mountains of data, hoping to find useful relationships. Instead of a problem in search of a solution, dredging data is a solution looking to find a problem. All of what I've just discussed about correlations does not mean that finding a correlation is without value. In fact, correlations are a vital part of helping us move to the next step, the discovery of causation. Unlike correlation, causation is when you can claim that one thing causes another thing to happen. In order to make this claim, you need to be able to demonstrate an actual cause and effect relationship, preferably a strong relationship. An example most of us are familiar with is the pharmaceutical industry. In order to make the claim that a particular drug causes a certain effect, such as lowering your cholesterol or growing hair, the FDA requires companies support those claims, putting the drug through a 4-phase, 12-step process that takes approximately 12 years. This process uses control groups and clinical trials to test the drug, making sure that X causes Y and that the drug is safe. The acceptable error rate can go as high as 5% for some drugs, meaning that the clinical trials prove that there's a 95% chance the drug does what it claims. Drugs with serious health implications, such as those used to treat a heart condition, are held to an even stricter standard, requiring proof up to 99% effectiveness. Back to ice cream. What about ice cream and obesity? While it may seem like common sense that it does cause obesity, the fact is that we don't yet know the true strength of the relationship. If we look at the sale of ice cream, there's actually an inverse relationship with weight. People gain weight in the winter when sales are low and lose weight in the warm summer months when more ice cream is being consumed. This might suggest ice cream is the new diet food. Luckily, you now know to be cautious of drawing conclusions of causation from correlation. Instead, recent research on the subject has been looking at different types of sugars used in making a wide range of sweet foods. What scientists have discovered is that the hypothalamus, which is an area of the brain that regulates the human appetite, reacts differently when we consume foods with fructose instead of glucose. This has researchers speculating that eating high fructose foods, such as ice cream, may result in people not feeling full, so they continue to eat. This theory proves difficult, however, when we start considering apples and other natural fruits also contain fructose, not just ice cream and chocolate cake. As you can see, causation is quite a bit different than correlation. Finding correlations is easy, proving causation is hard. No wonder it takes 12 years just to prove that a pill causes hair to grow. The bottom line, on the news, in boardrooms and coffee shops, everywhere you go, you will hear claims that X causes Y. From politics to the weather, from the stock market to personal relationships, it is human nature to try and explain things, to create stories that make sense. Just keep in mind, as you hear a claim of what causes what, that correlation is not causation.
So back to here, we understood that correlation is not causation. Causation. Okay, and as a researcher, what is like more interesting to find the relationship, causal relationship between A to B. There is another term which is known as the reverse causality. Sometimes A leads to B could be a kind of you will not get a significant uh, you will not get a support for this claim. So there could be a chances of B leads to A. So that is also known as the reverse causality. So these are the advanced level of the research. If you are purely in the research domain, then you will be able to get exposure of all these conceptual things. So somehow I try to tell you, I try to let you understand that how to treat the two variables as a correlated, and when you can think about having a kind of causal relationship, causality. So moving ahead here, so what is causal relationship? We understood the goal in establishing a relationship between two variables. So two variables, it could be two and more variables. So minimum requirement is two variables. Is to prove that changes in one explanatory variable causes the changes in the response variable. So what we understood here just two slides back, yes, X is considered out of two variables. One is explanatory variables and one is response variable. So in order to establish the causal relationship, you must have one variable as an explanatory and one variable as a response. Otherwise, you won't be able to set the causal relationship. For the causality, one has to be explanatory and one has to be response. So explanatory is X or response variable is Y. Sometimes it is also known as independent and dependent. So explanatory is your independent variable and response is your dependent variable. So changes in X will lead to changes in Y. So that's kind of relationship over here. For example, over here, the mother's BMI, do you think that that could be X and Y is your the daughter's BMI? So can we say that mother's BMI level is correlated with, not correlated, can cause increase or decrease in daughter BMI? So these are the areas like you can think about. Whether a person regularly attends religious services, that could lead to a person long lives. So that could be X, could be a causal relationship, or you as a researcher could be interested in knowing that does X leads to Y. I mean to say attending the regular religious services can give you more happiness, that could lead to more personal like more liveliness sort of. So these are cases of causality. You're trying to establish the cause and effect relationship between X and Y. Okay. So now a scatter plot, we already understood when during our initial weeks, something like a scatter plot. So a scatter plot is the appropriate graph to visualize the pair data. We know that the graph can be used to indicate if there is a linear relationship between the set of observation, or bit more. Yes, we have more. Okay. So the scatter plot, it shows that relationship between two numerical variables observed on the same subject or the objects. The value of the response variable Y appears on the vertical axis, whereas explanatory variable appears on the X horizontal axis. And if you could remember, like these are the four different scattered plots we have in front of. So what it says that is called scattered plot is a technique to see the kind of correlation between the two variables. So if you see the first one, positive correlation. The second is the case of negative. So positive correlation where you can imagine the slope is somehow in the positive, whereas in the case B, it's a case of negative correlation where the slope of the curve, it seems like it's going down. I mean to say the increase in the variable of X leads to decrease in the variable of Y. So it's a kind of negative correlation. Whereas in the first case, positive correlation, if a small increment in X will lead to the small increment of Y. That's why the curve is on the gradual increasing path. Whereas in the case of negative correlation, it's gradually in the decreasing path. There could be a case of,
So,
yes, please ask.
so in this situation, what does R mean?
Okay, we will have, like, I'm not explaining here, we will have lots of exercise.
Oh,
R is known as coefficient correlation. I will come up with that one. I'm just trying to explain you first the like different types of correlation. R is a kind of
okay.
strength. R is known as the coefficient correlation coefficient that gives a kind of
Okay.
strength of relationship. So see, when we talk about correlation, there are two things. One is strength and one is direction. Now I'm talking about the direction. Is it a positive direction? Is it a negative direction? Is it no direction? Or is it a inverse u direction? Or so I'm talking about the direction. R talks about the strength of relationship. If you see here, R values is in the first case 0.851. 85% of means that these two variables are somehow 85% are strongly correlated, but R could be minus 3.5, so 0.35, so 35%. So there are is like correlation, but the strength is weaker. But if it is, if above R equal to above 0.50, it means you can think about the relationship is also very strong. So we'll talk about the R and using the exercise. But over here, the positive relationship, the direction is positive. One increment in one variable will lead to the increment in another variable. So the negative correlation, one increment in x variable will lead to the decrement, like decrease, corresponding decrease in the value of y. So it's a negative correlation. There could be a case of no linear correlation, no really linear relationship. So if you see the dotted line, it's spread over all over the area. So it's very difficult to see any consistent pattern. Whereas in the case of A and B, with the dotted, if you see, you can draw a line in an increasing path, where in the case of B, you can draw a line on the decreasing path. But in the case of C, all the dots are unevenly distributed all over the area. So it's difficult to find out any theme, any consistent pattern. So we could say that in this case, R equal to 0 means there is no linear relationship. Scatter plot always gives you idea about the linear relationship between the two variables. Whereas in the fourth case is no linear relationship. It's a non-linear relationship. Although in the case of the fourth case, it says that there is a relationship, but it's not linear. It looks like inverted U relationship. So that is not a case of linear relationship. So scattered plot gives you all this indication to analyze the correlation between various variables. We'll talk about the R. R is known as coefficient correlation. So that gives a kind of strength of your relationship. R equal to 0, that means there is a no correlation. Whereas R can take any values from minus 1 to plus 1. So we'll talk more about that one. So interpreting a scattered plot, I think we discussed about that. So this is the case of, you see all the dots are in increasing paths. So we could say that number of branches, you see, you can have an interpretation also. What is there on the x-axis and what is there on the y-axis. So do you think that if any of the bank who has more number of branches, they can have more market share in compared to those who are having less number of branches? They might have less number of market share. So if somebody try to see how these two are related, they can find a relationship between the number of branches to the market share of the firm. And they found, one researcher can say that there is a positive correlation. I'm talking about the correlation. I'm not talking about like which leads to, is the number of branches leads to market share or market share leads to number of branches. I'm not talking about the causality. The correlation, in the simple term, we can say that yes, these two variables are correlated. I mean to say, where one can easily notice that if number of banks are, and those firms having more branches are gaining more and more market share, whereas those having the less number of branches are having less market share. So there is a kind of positive relationship. And what is the strength of relationship? That can be calculated using the R. So as the value of X increases, the corresponding value of Y also increases in the case of negative correlation. So, okay, this is the negative correlation. What it says, the temperature, as the temperature increases, natural gas consumption will be lower. Do you think does this make sense, this correlation? Anybody? Can you comment on this one? I got surprised, like why you're saying that, why somebody is claiming that if the temperature goes on increase, the natural gas consumption will be decreasing. Can anybody help me to unpack this scenario? Do you think that this is logically correct? Less temperature means more consumption of natural gas, whereas high temperature leads to less consumption of natural gas. Can anybody support this? Try it out. Try it. You must try. Speak. It's your time.
I think it makes sense.
Okay, explain it. Very good.
Because in the lower temperatures or colder weather, then you'll use gas for a heater. But if it's hot, then you won't use as much gas because you don't need a
Exactly.
heater.
So that is the one example. Think about the driving of car. You need, in the colder weather, you need more consumption of, something in order to keep yourself warm, not only inside the house, maybe the outside when you are going outside. So I have also seen that there are several scenarios. That's why I posted one link at the down. If you wanted to know that, what are the, how it is like, how to establish this relationship or correlation. So link is there at the bottom. You can later on, you just go through that. It gives you the indication that yes, this is something logically correct. So as the temperature, more and more temperature will increase, you will be less dependent on the consumption of the natural gas. So yes, it makes sense. But remember, as a correlation, these two variables are negatively correlated. And what is the strength of correlation? You need to find out while working on the manually, or the Excel sheet give you the value of R. We'll discuss about that. In the case of C, scatter plot says that there is no correlation, whereas in the D, shows that the distinct patterns suggesting a correlation between X and Y, but the pattern is not the straight line. So still in the case of D, you have a relationship, but it is a non-linear relationship, whereas the positive and negative relationships are linear relationships. So a bit more on the correlation exists between two numerical variables. I think we have covered the linear correlation. Okay, it's a repetition. Now here, because the conclusion based on the visual examination of scattered plots are subjective, we need more objective measures. Did you get that point? Just after viewing this one, we are making a claim that it is a positive relationship, it is a negative relationship, it is not. But we wanted to have some objective measures. And what is that objective measures? R is your objective measures. So R will give you the exact. So the value of R, if it is minus, it means negative relationship. If it is a R value is plus something, it's a positive relationship. So what is the objective measure here? The value of R is the objective measure. Although as a subjectivity, blindly we can say that this is a positive, this is negative, but we wanted to have something as a objective measures, and R is objective measures. So R gives you two things. One is direction and one is the strength. So what is direction? Negative or positive sign gives you the direction. Is it a positively correlated or negatively correlated? Whereas the value itself, like 0.85, strength is more because it's closer to +1. R value lies -1 to +1. So if R is equal to -2, like 0.21, so the strength of relationship is lower, although they are correlated. So that's what is the discussion here. We need more objective measures. So for that, we use the linear coefficient correlation coefficient R. So remember, R is known as correlation coefficient, which is the value that measures the strength of the linear association between the two numerical variables. So strength of relationship, whereas the sign plus or minus gives the direction of the relationship. These two are important steps of understanding in the concept of correlation. When we examine a relationship between two numerical variables, it's important to measure the variable on the same cases. Is the purpose of the explore one variable or response? I think we have covered all these things. Too much slides, too much content on the slides. I don't know. It's kind of sort of repetition, but I'm assuming that everything is going well in your mind. So talking more about the coefficient correlation or correlation coefficient R. The linear correlation coefficient R measures the strength of the linear relationship between the paired numerical X and Y value of sample. Because R is calculated using the sample data, it is a sample statistics used to measure the strength of the linear relationship. Oh, okay. So you see R, we calculate R for a sample data. not for the population data. So R is also known as the sample statistics, not the population parameter. So you you never think about, you never suggest that R is a kind of population parameter. It's a kind of sample statistics because the calculation of R is dependent on a small data. We'll see with the example. Some of the property I was keep repeating the same thing, but just have a kind of the correlation R, correlation coefficient R is always a number between -1 and 1, inclusive, including. So we can have 1 and -1, including. The value of R is not affected by the choice of X and Y. This is very important. Even if you change the scale, suppose one time you put on a x-axis X and Y on the y-axis, and you got R equal to suppose 0.50. If you change this to axis, I mean, if you put Y on the x-axis and X on y-axis, still the value of the R will not get affected. So interchange of all X and Y values and the value of R will not change. R measures the strength of a linear relationship. R is very sensitive to outliers in the sense that a single outliers can dramatically affect its value. Outliers, you know that outliers means some of the data which are like not in the consistent pattern. They are, I mean, outliers is like the extreme values. So it may distort, distort or gives you kind of value of R which is not maybe correct for the experiment. So it is sensitive to R outliers. Why? Because while calculating R we use all the data in the sample. So if you have more outliers in the sample itself, the R value will be distorted, or it will be not a true representation of the strength of the variables. So that just keep in mind. Correlation coefficient R is calculated as follows. So if you wanted, you can make a note on your paper that how R is being calculated manually. So R is a kind of, in order to calculate R, you need to divide S. S is a standard deviation for X and Y together, divide by individual standard deviation for X, individual standard deviation for Y. And remember, X and Y are the two different sets of data. I'm talking about maybe with the example over here. Okay, consider this one as a X and Y. So
Could we go back to the last slide?
over here,
The slide number 25.
yes.
Could you explain that again? I don't understand the difference between standard deviation XY and the other one.
Okay, the first to calculate the numerator. What is denominator? You have XS, SX, and SY. That is the standard deviation for value for X and Y. You imagine this set of data, X and Y. X we have 10 values, and Y we have 10 values, right?
Yeah.
So the SX will be the standard deviation of X, whereas SY will be the standard deviation of Y, all the 10 values. Yeah. Okay, that is the denominator. Thinking about the numerator, you have the separate equation. You see here where SXY is summation of Xi minus X bar. X bar is the X mean.
Okay.
Into Yi minus Y bar. Y bar is the mean. Whole divided by n minus 1. So this is the way to calculate SXY. And if you differentiate, if you divide these two, you will get the value of R. With the examples you will understand, but just note it down on a paper. This is the like general notation for calculating the value of R. So we assume that the denominator is never equal to 0. We assume that. Otherwise, some numbers divided by 0 will give what? Infinity. So we are assuming that so n has to be minimum 2. So 2 minus 1, it will be 1. You can't have a kind of correlation coefficient for a single variable. So if n equal to 1, you can't. So round R to a 3 decimal. Okay. So this value can be calculated from given values or found using the Excel.
Sir, sorry about the standard deviation. Will it like be in the like final exam? Will it be given, or we're gonna have to compute it using this?
Exactly. I will take you. I think it will be given. Don't worry. So maybe with the kind of exercise we will do, I will keep you telling that how it will be. Okay. But you remember how to calculate the standard deviation, the variance, standard deviation, mean, mode, median. Everybody you know. So you need to be happy that you know how to calculate.
Okay.
And something is given for as x y, you have the another notation to calculate. So it's easy to calculate using this sort of. But I will let you know what will be form of exam.
Okay.
What are the requirements for the R? The data has to be a sample, random sample. The plotted points in the scatter plot appears to straight line pattern. That's okay. And the scatter plot shows that there are no outliers. You see in this example, find the linear correlation coefficient R for the following data. Suppose this will be given in your exam. X has having a 10 data, 1, 2, 3, 4, 5, yeah, 10 values. Y, another. So X is a, we are not sure about which one is the independent or which one is the dependent, which one is the explanatory and which one is the outcome. Why? Because we are interested in correlation, not causation. Since it is not a case of causation that X leads to Y or Y leads to X, we are not interested in identifying the causality. So we are just interested in correlation. Is these two variables are correlated or not? Is the ice cream is correlated with the obesity or not? So we are just interested in correlation. And for that, if there is a correlation, linear correlation, then what is the value of R? So for this sum, what I did, I plotted on the, so we have the scattered plot. It gives it gives you this kind of uh, X and Y on the different axes. Okay, if suppose the question will be like you have to do it manually, then these information will be given, like X equal to for X mean value, median, standard deviation. For Y, mean, median and standard deviation. And S XY value 368.71 will be also given to you. So with the example, with the formula, can you calculate R value? Anyone, can you try? Can you calculate R value? I'm switching on the board now. R equal to, as I said, which was on the numerator. Okay, so it was capital XY SX SY. Is that the correct one? Let me check once again.
Yeah.
Okay. Yeah, SXY XY. Yeah. Okay, so you for the manual calculation, all this information will be given to you in the exam. So what is the SX value? 368.71. Divide by, what is the standard value of X? The standard deviation of X is 61.31 into the standard deviation of Y, 6.73. What is the value of R?
0.8936.
Let me write down 0.89
36.
8936 or 38. Okay, 36, whatever. So your answer is close to that. So going back to the slides once again. Okay, over here. So If you simply apply this formula, which we have seen, you will get the standard R value as 0.8936. And that's what Excel is also giving, 0.8938. How you will interpret this result? If there is a linear relationship, correlation, that is R is greater than 0, and then it's got to imply. Okay, can we do it this sum quickly on the Excel? Open Excel sheet. Open Excel sheets and try to do this sum. So I'm trying to do the same sum using the Excel. So what happened? I'm not trying to close. Okay. So Excel sheet is in front of you. Are you guys able to see the Excel sheet?
Yeah.
Okay. So this is the data. What I will suggest you to just quickly write down all this 20 information on your Excel sheet. For X, all the 10 values, and for Y, all the 10 values. I want everybody, every one of you, please do it in your Excel sheet. Go to data, data analysis. Over here, you have an option of correlation in the data analysis. Choose that one, correlation. Okay. They're asking for input range. You select all together. You should not have a kind of X or Y separate. They're asking because the correlation between two variables, so select all the 20 values together. Enter column, I have accepted the label. Output range, I want it to be here. So I gave the output range. And then press OK. Did you notice that same correlation R value we got it using manually? Is it the same? 8938? Yes, 8936. So this is the way to calculate the R using the Excel. Is that clear?
Yes.
So now we will do something more. Okay, so there are another way. So what we can do is now in the second case, go to data analysis and go through the regression. Now we are, because the today's topic is correlation and regression. Regression means establishing the causal relationship. Establishing causal relationship comes under the term regression. So in the analysis tool, just pick up the term, the tool which is known as regression, and then press OK. In the regression, they are asking for Y input and X input. I think this is not the right time to go through regression. I haven't taught you. Maybe after some slides, it will come the regression. Let me go through this one. Okay, just hang on then. I'm a bit fast, so it's better to go through some of the slides, then we'll come back to the regression. Okay, so anyhow, you understood how to calculate the coefficient, correlation coefficient R using this formula, or otherwise how there are ways to calculate the value of R using the Excel. Okay, this is the correlation scale, which varies, as I said, it varies from -1 to 1. So if it is a 1, the correlation strength is very, very strong. If it is in the range of 0 to 0.3, we can say that there is a little or no correlation. Whereas in the range of zero point 0.3 to zero point 0.5, it is a weak correlation. From 5.5 to 0.8, we can say that there is a moderate relationship between these two variables. Whereas in between 0.8 to 1, we will say that it is a very, very strong relationship between these two variables. Irrespective of the sign, we have the same interpretation if in the case of R negative. So even if R is suppose minus 0.85, we can say that there is a strong correlationship, but it's a negative. So negative strong correlationship. Is that clear to everyone?
Yes.
So this is the correlation scale. Okay, now we have another term, that is R square. So R is known as correlation coefficient, whereas R square is known as coefficient of determination. So the value, what it says, that once we have calculated the linear correlation coefficient R, we can use this one to find out the proportion of the total variance or variation in the Y that can be explained by linear correlation. So R square, R square is a kind of variance. If you get the value of R, then using that you can calculate the value of R square. That is known as coefficient of determination. That is R square. This R square gives you an indication about the explained variance. X leads to Y.
So sorry, what's it called again? R squared, coefficient of.
Coefficient of, okay, it's a coefficient of determination. Wait, where is that? The coefficient of determination, R square. Just making it, if you have the value of R, just multiply or just square it, you will get the coefficient of determination. So the value of R square is the proportion of the variation in Y that is explained by the linear relationship between X and Y. I think it's better to go through the Excel sheet now, because there will be lots of interpretation using the Excel sheet. Okay. So I'm opening that Excel sheet once again. Over here. Once again, go to the data analysis, and then you have regression. Select the term regression, the tool, segregation, and OK. They're asking for input Y range and input X range. So now we are assuming that Y is dependent and X is dependent. So we are moving ahead from the correlation to the causality. For causality, as I said, you need to have a kind of regression output. You need to run the tool, which is known as regression. So once I'm assuming that the correlation is clear to you. Correlation means knowing the strength and the direction of relationship. That part is over. Correlation is over. Now we are moving towards causality, the regression, trying to establish the relationship between two different variables. So in this particular case, we are assuming that y is dependent variable, x leads to y. So we are assuming that y is dependent variable, whereas x is independent variable. And we are trying to see that is there any relations. So we understood with the correlation there is a relationship with the strength of 0.8936, and this is the positive linear relationship because the sign of r is positive. So that part is over. Now we are trying to see that is there any causality between x and y. Does x leads to y? X is independent whereas y is dependent. And in order to check that causality, we are running the regression equation. So what is input y range? So we are assuming that y is our dependent one. Input x range, x is our independent variable. I'm using the level, so I'm putting level, yes. I'm just keeping the confidence level 95%, although there is no need, but just keep it because we'll see that some of the output will give you kind of confidence interval estimation at the 95% interval confidence level. So I'm just taking that one. Output range, I want it to be have a output over here. Okay. Nothing else. The residual plot will be that at the end. We'll see that. Okay. So just after doing this, just press OK. A big regression summary will be in front of you. And now, very important is to analyze these outputs, these outcomes. So over here, summary output, regression statistics. So that means these are the output of the regression analysis where we are trying to establish the causality. For the same equation x and y, over here you see the multiple r or r. Did we get the same value when we calculated using manual one or the different using the different way of in the Excel sheet? We have calculated the r value. Is it the same r? Yes, 0.8938. You could see the same. The regression is also giving you the value of r. It is a 0.8938. So what is the interpretation of r here? There is a positive relationship because the sign is positive. So there is a positive relationship between the variables x and y. And what about the strength? 0.89. So it falls under, it's a strong. So we can say there is a strong, yes, there is a positive, a strong relationship, correlationship between the two variables x and y. That is the interpretation of r. So now the second one is r square. I'm talking about here, the coefficient of determination. Even if you make a square of this one, just equal to square of, no, square is, where is the square? Okay, this one, probably this one will work. Yes, if you make a square of this, multiply the same once again, you will get the 0.798933. So that is the value of r square. But what is the interpretation? How you will interpret the r square? That is important here. R square is known as coefficient of determination, which explains the variance. So how to have an interpretation of r square 0.7989? For that, you need to go through this slide. But it says that r square is the proportion of the total variation that can be explained. We conclude that certain percentage of the total variance in y variable can be explained by the variable x. So in this case, what we can write here, this one is very important for everyone, because maybe in the exam, I will give you the straight with Excel output and I will ask to have an interpretation for that. So how to interpret, make an interpretation for r square? That value is coming how much? 0.7. Let me go through that. 0.7989. So I'm writing here R square value is 0.7989. 0.7989. And we using this slide, try to make an interpretation of the term R square, which is coefficient of determination. So we can say that, we conclude that, so we can write here, we conclude that that percentage of certain percentage of the total variance. So 79 point, we conclude that 79.89% of the total variation of the total variation in the y, in the variable y, or y variable can be explained by y variable can be explained by the x variable. I'm switching here on the board. I will have like more interpretation on the R square, but it's very important to understand. So with the Excel chart, we have seen that R square value is 0.7989. So we can convert it into the percentage. So it's a 79.89 percentage. So how to interpret this R square value? This sentence is very important for you. We can conclude that 79.89% of the total variance in y variable can be explained by the variable x. So go back here. What is happening here? What is happening here? Let me delete this one. This part is not relevant now. What we are saying that the two variables x and y. So x is going to lead to y. We are assuming that there is a causal relationship between x and y. And for that, R square value is coming 79.89. So 79% or around 80% of the variance in y is explained by x. Do you think this is x is a, I wanted to have a kind of discussion here. Do you think that x is a good predictor of y? Can we say this is the predictor and this is the dependent? This is independent and this is dependent. Can we say with this one, it's around 80%, right? Keep it like 80% of the variance in y can be explained by the variable x. Can we say on this basis that x is a good predictor of y?
Yes.
Yes. Why?
Yeah.
Almost 100%.
Exactly. How much is the total? It's 100%, but out of 100%, 80% of y is being explained by x variable. It means there are another variable which we are not exploring in this research. That could be, suppose this is x, that could be y, like maybe another variable could be kind of w, kind of t, or kind of z. These are the variables which are going to explain only 20% if I will include in this model. But 80% is 80% of the variation in y is being explained by the variable x. That means, that indicates that x is a good predictor of y. I mean, if I'm having a variable x and y, I'm more reliable. My assumption is more and more kind of valid, because the R square value is going to give you indication that 80% of the variation in y could be only explained by using one variable. So think about, if I'm making a model of x and y, and if I'm not keeping this variable, particularly this variable in the model, that means all these variables will be accounted just for 20%. So it means if we have a model of x, y, w, t, z leads to y, can we say this is a good model? No. The second model, try to think about two different models. One is model X leads to Y. So where X is explaining 80%. Where another model is another variable W, T, Z, we don't know. But that that could also leads to the variable Y. But it's going to explain only 20%. So that means this model is not a good model for the analysis. Whereas this model is a good model for the analysis. Why? Because on the basis of R square, we are making this decision that the 80% of the variance in Y can be explained by a single variable, independent variable, that is X. So X is indeed a good predictor of Y. There could be other one, which we are not capturing one in this experiment. You know, the other variable generally known as control variables. So we will not go in detail. These variables are known as control variable. This X is known as the independent variable. Whereas Y is known as the dependent variable. So altogether in the experiment, we have three sets of variable: dependent variable, independent variable, and control variable. Leave it this one, but remember here, we were trying to understand the importance of the term coefficient of determination, that is R square. How to make an interpretation of R square? We conclude that 79.89% of the total variance in Y could be explained by the term, by the variable X. And accordingly, we can say we can make a conclusion, X is a good predictor of Y. So that interpretation is very, very important. Is there any doubt? Going back to the Excel sheet. Okay, so you understand, I'm assuming that now you understood the importance of R square. There is another term, adjusted R square. It's not much important for you, but you could see there is a slight difference between the adjusted R square and R square. Very slight, 1 or 2%. So that gives you more clarity, there is some internal mechanism which gives you tells us that more appropriate value to consider is adjusted R square instead of R square. But not much difference. It's only 1 or 2% slight difference. Standard error. What is the standard error? Remember the margin of error? Standard error is the margin of error. We are not talking about it here, but standard error is the same as the margin of error we calculated while calculating the confidence interval estimation. Observation is 10, right? Okay. Now the ANOVA is giving you the regression output. ANOVA is the technique. So what output is coming? Regression. What is important here? What other things which is important to have for the analysis that we are trying to understand now? And this is very, very important. Remember, in the exams, you will have this sort of output. I will give you the Excel output and I will ask for the interpretation. Now you could see here, what is coming here? Okay, let's go back to the, okay, one by one. Let me go through the slide first. We understood the coefficient of determination. Okay, and we have, so other 100 minus might be explained by some other factor or the random. So we understood the other factors, W, T, Z or other variables that will be explaining the remaining percentage of the variance. So interpretation of R square is, I hope it is clear. Okay. Find R square and interpret this value. We did. Now the question is now regression line. So this one is very, very important for your exam again. One Excel output is giving so many data, so many things for analysis, and we are trying to understand each and everything. So how to formulate, what is the regression line now? We are assuming that X leads to Y. Can we write a kind of equation? We understood that X is indeed leading to Y, and X is a good predictor of Y. With that, idea is, can we frame a linear equation? I'm talking about the equation now. Can we write a regression line or linear equation? So regression line or linear equation, both are same. We are saying x leads to y. In that case, we can say that y is something, y can be, y is a function of x. Right. We're trying to establish the relationship, causal relation between x and y. But we are trying to now, the purpose is to find out the equation of the line. We say that there is a linear relationship with the strong coefficient correlation, positive coefficient correlation. All these data are we have. But what is the linear equation there? If it is a linear relationship, there must be a kind of equation. Now we are trying to find out those linear equation. So we are assuming that we are considering the y is a function of x. So this is, but what is exact equation? What is the exact regression line? That we are trying to find out. So the regression line, we can find a linear equation that expresses y in terms of x. So y is a function of x, and the equation can be used to predict the value of y for a given value of x. Let's see. This one is important here, the regression line. We are now going to find the equation of the straight line that best fits a scattered plot of the sample data. The best fitting straight line is called a regression line. Best fitting, remember the best fitting straight line. There could be a different line possibility, but the best fit is known as the regression line, and its equation is called as the regression equation. We can use the regression equation to make a prediction for the value of y for a given value of x. I mean to say, I'm trying to find out what is the value of y as an equation, where we can say b naught plus b1x. We're trying to formulate this sort of equation. We're trying to formulate, we are trying to formulate the equation. As I said, we blindly know that y is the action of y is a function of x, but now we are interested in knowing the exact equation. Equation could be, linear equation could be, what is the basic form of linear equation? It is a y equal to b naught plus b1 x. So y is a function of x. What is b naught? B naught is a kind of constant term. This is the constant. And b naught is the intercept of x. This is known as intercept x. I mean to say, if you see the y, x and y axis, right? So suppose this is the straight line, and we wanted to know the equation of this line. So if the equation of this line is b naught b plus b1 x, that means this is x and this is y. Try to understand what is b naught here. This is the intercept. So this is in this this one is known as b naught. This is the constant. This is known as b naught.
You can't see the whiteboard on the other side. Yeah.
Now?
A little bit to the side. Yeah.
Okay. So in the x and y, we have x and y. And this is the graph. This is the line. And we are interested in knowing the equation of this line. So if I'm writing this equation is as a b naught plus b1x. So what is b naught in this case? B naught is the intercept. So this one is known as b naught on the y-axis, where it meets this line meets the y-axis, that point to the 0. This difference is known as b naught. What is b1 then? b1 is the slope of this line. So if you, this is b1, this is the slope. This is so this one is b1. So considering b naught and b1, the equation of this line will be, we can write y equal to b naught plus b1x. This is the normal interpretation of the line. Going back here. So the regression equation y equal to b naught b1x mathematically describe the linear equation. which I was trying to show you using the graph. So what is B1? So you see here, the Y is the predicted response variable. Y is the equation. B naught is the intercept. Remember here on the x-axis, on the y-axis, the intercept where the line cuts the vertical axis, that point and down to 0. That is the intercept. B1 is the slope. As I said, this is the slope of this curve. So this is the slope. And x is the explanatory variable. So x and y. So this is the interpretation. Quickly, can you note it down, this one? If in order to get this value, this equation we wanted to have, we have y and x, but what we wanted to know, what is the value of b naught and what is the value of b1. So how to calculate b1? It will be r sy divided by sx. And how to calculate b naught, the constant term, that is y bar means mean of y minus b1, which you have calculated, into x bar. Otherwise, if you want to do manually, you have to use this one. Otherwise, Excel sheet will give you this value. Let's see how to interpret the values on the Excel sheet. So idea is to get the value b naught and b1 from the Excel sheet. Okay, over here you could see, if I can increase this one, where is the value of b naught and b1? Intercept, as I said, b naught is the intercept, constant intercept. So intercept, what is the value is coming at the bottom? You could see the Excel sheet gives you the b naught is 0.594. I'm just writing here, b naught value is 0.594, whereas b1, that intercept value is coming, b1 value is coming, sorry, is 0.098. 0.098, that is the slope. This one is the Excel sheet output, right? You can do it manually also, but I'm giving the Excel sheet. Using this formula, you can calculate b1 and b naught. That is okay. But just go back to the Excel sheet now. Over here. So Excel sheets gives the intercept. Is it the same one? Intercept, yes. B naught we got 0.594 and X value we got 0.098. So the regression equation also we got the value of intercept, and these two values are important for us in order to frame the regression line. These two values, intercept and X, these two values are important for us. So now, can we quickly on the basis of this Excel output, can we quickly frame the equation? Can we write the equation here? Regression equation. What will the regression line now? Regression line. Y equal to, where it was? Okay, y equal to b naught plus b1 into x. Taking it here. Okay, so this is the regression line. I'm trying to write the regression line. So y equal to b naught plus b1 into x. What is the b naught value from the Excel sheet? B naught we got 0.594. So we can write 0.594 plus the B1 value 0.098 into X. That is equation equal to Y. So this is the regression line. It's easy. If Excel sheet will be given to you, can't you frame the regression line? Will it be easy or not? If the Excel sheet output will be given, can you formulate this regression line?
Yeah.
It will be easy because you need to just find out B0 and B1 value. And in the Excel sheet, we got that. Where is the Excel sheet? You see in the Excel sheet, which I highlighted in the yellow background, 0.594 is the intercept, and where is the X value, B1 value is 0.098 into X. So this is the regression line. So once you have calculated that you have the like regression line, if I'm asking you what is the value of, what will be the value of y when x equal to 10, how you will do that? What will be the value of y when x equal to 10? So simply you have to write 0.594 plus 0.098 into 10. That will give you the value of y10.
It equals 10.394.
Yes. So it will be not 10 point, right? It will be 0.98, right? And plus 0.594. How much is the answer? 1 point. Just multiply this part with the 10. If x is 10, what is the value of y?
Oh, okay. I got 1.574.
Exactly, something like that. Yeah, right. So that is the value of y when x equal to 10. How you are able to calculate this one? Before that, it's important to calculate the regression line. The equation, once you have formulated the equation, then you can find any of the values. So go back to the Excel sheet here. This part is the remaining, which is important. So it's got, so we'll try to see like what like I'm suggesting you know the where is the scatter plot? On the top. Select this scatter plot. So what you, for that, before that, just select x and y all together, all the 20 values. Just select that one, go to the scattered plot. Yes. Can you see a scattered plot in front of you? Everyone, are you able to see one scattered plot in front of you?
Yeah.
Yes.
Okay. So once you got this scattered plot, what you can do, click on one of the object which is in blue, make it right click, and then there is an option here, add trend line. So just add trend line. You see there is a positive line has been created. So that is the regression line, the more fit line, the best appropriate line is the regression line. This is the regression line. But further, I'm interested in knowing the equation of this line. So what we can do, in the right side, format trend line, there is an option here, display equation. I just simply click that, display equation. Now you have the regression line in front of you. And do you think this is the same as what we have? 0.594 plus 0.098 into x. So this is the regression line. We can calculate, we have seen using the Excel sheet also, using the scattered plot. They are also giving the same equation line which we have formulated using the Excel regression output. Is both, do you think both equations are same? Is that same equation which the Excel sheet is giving you?
Yeah.
Yes.
Where do we find the, oh, okay, never mind, I understand.
Got it?
Okay, yeah.
Okay. So in the exam, as I said, you will be given all this Excel output, and we will ask you have an interpretation of R square, and then what else are there? Like some more variables are there on the Excel output. Yeah. So go back here in the slides. So we understood and we formulated the regression line. Manually, you can get the value of B0 and B1 using this formula. Okay. So prediction. Regression equations are useful for predicting the values of the y given some specific value of x variable. I mean to say, using the equation, can you predict the value of y when x equal to 0? Yes, you can do. The same line, if x equal to 0, it will be, how much it will be? 9.8? 9.8 plus 0.54. Can you get, what will the value of this one? Predict value of y. Do this sum. They're asking for predict the value of y when x equal to 100. So y 100 will be 0.594 plus 0.098 into 100. X equal to 100. So just put in x equal to 100. So this part will be 100 means 9.8, right? Yeah, 9.8 plus 0.594. How much is the final answer? Anyone? What is the final answer? Predict the value of y at x equal to 100. So in this equation, simply put x equal to 100. So 0.98 into 100, it will be 9.8 plus 0.94. This is the constant term. So altogether, how much it will be?
So it'd be like 10.39 something.
Something, right. So that is the answer. It's easy because you have the regression equation, so you can formulate it anytime. Okay. Then you have confidence interval as an output. We know that. See in the Excel sheet, what is the confidence interval you are getting? It is giving lower 95% and upper 95%. So what is the confidence interval for your B1? Not for the constant. B0, we will not consider the confidence interval. So we are only interested in the confidence interval of the intercept. So that is B1. So where it lies, 0.058 and 0.138. This is the confidence interval for B1. So we can say we could say that B1, not B1, B0, not B0, B1. B1 lies in between 0.058 and 1.138. This is the confidence interval estimation. This B1 lies between 0.058 and 0.138. So this is the confidence interval estimation for B1, your intercept. Right, and that is coming from where? That comes from your regression output. It gives you the, because we have selected 95%. If it is a 99%, you could have done it replacing the 95 to 99. But over here, if you remember, before running the regression analysis, we put it 95%, and that is the by default. So at 95%, what is the value is coming? What is the confidence interval is coming? That is 0.58 to 0.138. That is the interval. Another analysis is, what do you think? Can we reject, or at 95%, do you think this model is like reliable? I want somebody to comment on this one. Do you think this model is reliable? This question is very important. At 95% confidence interval, or maybe you can say, my question is at 0.05, 0.95% means 0.05 level of significance. Can we claim that this model is significant? Or can we say that at 0.05 level of significance, can we have a claim for X is leading to Y? Can you comment? This question is very important. For that, is it reliable or not? You need to see the value significance F. What is the significance F value in this Excel output?
0.
0.000. That is the p values, I mean to say.
Okay.
So significance F is a p values. So what is the p value over here? P value is 0.000. And what is the level? What I'm saying that alpha is 0.05. So 0.00 is less than. This is important. What I said, 95% is our alpha. So alpha is 0.05 and the significant F in the Excel sheet is 0.000. So 0.00 is less than 0.05. So that means what we will do? We will reject. P value is less than alpha value. We will H naught must go. So reject H naught. So what is the reject H naught in this case? We are assuming that there is a relationship. So what is our H naught and what is H naught and what is HA in this case? H naught or HA? H naught and HA. What think about that? What will be the H naught and HA? That is there on the slide. See here. In the previous lecture, it was discussed that the confidence interval can be used as a hypothesis test. We have done this. Using the confidence interval, we try to see that if the zero value, if you could remember, hypothesized mean value was 0 and if it falls between the CI interval, we were saying that not rejecting null hypothesis. Otherwise, reject. So something we did it before. So for this regression model, what is the hypothesis? Hypothesis is there is a relationship or there is not a relationship. So what is null hypothesis? For this X leads to Y. What is the null hypothesis? There is no relationship between X and Y. Whereas what is our alternative hypothesis? There is a relationship between X to Y.
Sir, sorry. Regarding the null and alternate hypothesis, is it like automatic? It's always like this, or you have
Exactly. It's automatic. We don't have to.
Okay.
It's automatic. So see, now we are in the higher level, advanced level of understanding. So I'm assuming that all the basics understanding is like with you. Otherwise, I can't take you to this level. So I'm assuming that it is everything is there, you understood. So yeah, this is automatic thing which is there in the regression. For each regression, this is the kind of assumption which is inherent, which is there. So what for this regression line? So there is two possibility. Null hypothesis is there is no relationship. So B1 is 0. Alternative hypothesis is it's like there is a relationship. So B1 is not equal to 0. So in order to see this claim, go back. We have the B0 value, B1 value, which lies between 0.58 and 0.138, right? So using this one, what do you think? Is it null hypothesis has to be rejected or accepted? Do you think the 0 lies between these two? In this interval, 0 lies? No. In this confidence interval of B1, two different ways to have a claim for the hypothesis, right? One is hypothesis, there are two ways. One is hypothesis testing, p-value less than, and the second one is using the confidence interval. So we will try to see using both. So using the confidence interval, what we got the B1. In the Excel sheet, we got the B lies between 0.058 to 1.138. Since 0 doesn't lies in between, what we can do, if 0 doesn't lie, we didn't get a support for null hypothesis. So from this, we can say reject null hypothesis. And null hypothesis was B equal to 0, B not equal to 0. What is B? B is the value of, this is the value of B. So we got the range. So with the interval, we are rejecting H naught. Second way is to look at the p-value. And what is the p-value in the Excel sheet? I just said in the Excel sheet, what is the p-value? Is the significance as. Let me open the Excel sheet for you over here. Okay. This is the significance as. I'm highlighting here. You could see here. In the red font, the significance f value is your p-value. So p-value is coming 0.000. And the alpha value for this calculation is 0.05. Since p-value is less than 0.05, over here also we can, what we are getting, what kind of conclusion we are getting? We should reject the null hypothesis. P-value is less than 0.05. So reject null hypothesis. We are getting the same thing using the confidence interval estimation also. Since 0 doesn't lies in between 0.058 and 0.138, we should reject the null hypothesis. So over here in this method, reject null hypothesis. P-value method, reject null hypothesis. What is null hypothesis? B is not equal to 0 means there is a relationship. If B equal to 0, if beta, this is the beta value in the B1, this is the B value, right? If this will be 0, means what will happen? There is no relationship between X and Y. In order to have a relationship between X and Y, B should be some value. B should contain some value. I mean B1. If B1 is 0 means there is no relationship because whole part B1 into 0 into X, 0. So Y equal to B naught. There is no relationship between X and Y we are talking about. In order to have a relationship, we must contain some value. So it should not be 0. So null hypothesis is B equal to 0. But alternative is, so we are rejecting the null hypothesis means we are getting the support for alternative hypothesis which says that B is having some value. It means there is a relationship. So using this Excel sheet, we can say that this is important finding here. Not this one. Using this Excel sheet, can you say now is the finding is reliable? Can we say the relationship is reliable at 0.05 significance level? Can we say? Could we say that? Anyone? Could we say that these findings are reliable? Make some comment.
When you said reliable, do you mean like they have relationship with each other? Is that reliable?
Reliable means it's a significant. Is the relationship is significant?
So it is reliable in this case?
Yes, because it's reliable. We are rejecting the null hypothesis. So we have a support of alternative hypothesis. What is alternative hypothesis? There is a significant relationship between X and Y.
Mm-hmm.
But imagine if the value over here, imagine if I'm taking the example, suppose the significant value could have been, imagine I'm replacing it with the 0.12. In this case, in the second case, can you say that this is reliable at alpha 0.05? No, because the p values is coming greater than 0.05. So if the Excel output gives you the significance f value 0.012, can we say this relationship is reliable? No. Why? Because the p values is coming greater than 0.05. So in that case, we should not reject null hypothesis. It means the null hypothesis, there is no relationship. That makes sense? Does that make sense?
Can you say that again? Sorry.
Think about in another case when significant f value is 0.12. I have written in front of you in the Excel sheet. I have replaced the previous value. So now it is 0.12. Can we say in this case the relationship is reliable or significant?
So no, because 0.12 it's greater than
Exactly.
0.05.
So we should not reject null hypothesis.
So we rejected anything less than like
Yeah.
the given number.
Yeah.
Okay. Okay.
So try to understand the importance of the significance f value. Significance f is same as the p value. So although we have seen the regression line is there, everything is there, but this relationship is not significant. We can't say that x is going to lead y because there is no support. So everything, the p values is very, very important. And significance f is the p value. So straight away you look at the significance f value and just make a conclusion that since this one is less than this, we can reject. So there is no significant. Although there is a relationship, but this relationship is not significant. As a researcher, we can't have a claim. I need to say. And on the basis of that x leading to y, we should not make a new drug. It will be a kind of a disaster because the relationship is not significant. So what matters? The relationship has to be significant. Then only you can have a proper claim that this is going to lead this. Otherwise, not. What is remaining now? So we understood the confidence interval. So there are two ways using confidence interval. Also, you can check the is it significant or not. Otherwise, look at significance f value and just take the decision. I've given you the hint at the bottom also in the slide. So this part is covered now. So for the regression, yeah. Small exercise here. Researcher looked at the relationship between foot length and height. Foot length and the height was measured in centimeters. A random sample of 40 subjects were measured. Okay, and what kind of observation you have? Is it what kind of correlation between foot length and height? Positive, negative, any comment?
Positive.
It seems like positive. We can't say it's a decreasing one. What about R? Can you by observation can you make any guess about R? No. For that, what you need, you wanted to have Excel output. What is R value for this one? 0.842. What is the strength of relationship between foot length and height? If R value is 0.842.
Strong or very good.
Exactly, it's a strong one. Something in between 0.8 to 1 is a strong. So we can say now a strong positive relationship between foot length and height. That is the interpretation of R. What is the interpretation of R square? Quickly. 70%. Can anybody try? 71. Okay. Can anybody try the interpretation of R square? Nearly 71%. So nearly 71% of the variance in Y. What is Y? Y is height. So this around 71% variance in height can be explained by the variable foot length. That is the interpretation of R square. Then you have adjusted. The significance level is again, see, very less. Something e to the power minus 12. That means 0.000000000 something, and then 1, 5, 1, 2, 3, 5, something like that. So that is, what do you think? It's a significant. It's a reliable because the alpha value, p value is less than 0.05 or 0.01. For this one, can you write the regression equation? Can you try? What will be the regression equation for this one? Quickly we'll do and then we'll finish today's session. Although it was long, but I'll do it quickly. What is the regression line for this equation? Regression line will be, can anybody suggest what will the regression line here? What is X and what is Y? If the output is given, what is X and what is Y? Anyone? What is X and what is Y? You have two variables. One is height and one is foot length. Which one is X and which one is Y? If the Excel output is given to you. No idea? Anyone try?
Would the X be the foot length?
Foot length is X or Y?
X.
Exactly. So what is given at the round? So yes, you're right. So we have Y equal to V naught plus V1 X. So then what is Y? Y is height. So height is, so what is the proper equation? Height equal to V naught. What is the value of V naught? That is intercept. 64.12. 64.12 plus, what is the B1? 4.29. 4.29 into, this is X. What you said is right, foot length. So the regression equation is height equal to 64.12 plus 4.29 into foot length. That is your regression line. Can we say this relationship is reliable? This, yes, because the significant value of f is 0.00, so that is less than. Otherwise, look at the interval. Okay, that part is okay. What? Oh, you have lots of interpretation here. Can we do it, the question number 6? Use the sample data to predict the height of a subject who has a foot length of 28.5 centimeter. So what is the foot length they are saying? Foot length is, they are saying X equal to 28.5. And they're asking for what is the height. So can you get this one value? Height at 28.5. That will be equal to 64.12 plus 68.42 plus 4.29 into 28.5. You will get the value. That will be the answer for the height. That is the part of the question 6 here. Anyway, in the coming tutorial, we will have lots of exercise. Probably we'll take this example once again over there. So with that, I think any doubt, or should we close today's session? If you have any doubt, please ask. Don't worry, we have a kind of tutorial session, 2 hours. So I will take this exercise and then again I will start. So meanwhile, you just try to have a kind of till Friday, just try to go through the concepts once again, all the concept which has been taught today, and let me know, have a kind of discussion on any of the things which is not clear to you. And then we have in the exercise today, like Friday exercise, we have 4 or 5 different big exercises with the Excel output. So you will have a good understanding of the regression and correlation and regression. All good? I hope everybody has marked their attendance in the chat box. And with that note, I'm supposed to close this class today's class.